we're not even using it, are we? So we're always going a specific direction in the domain, which would make all this stuff kind of work wrong, wouldn't it? Well, I would definitely suggest, if you have the GitHub skill and all that, to grab the source from the latest stable release from Unreal and build the editor yourself in Visual Studio or whatever else you're using. It really helps if you're going to be writing C++ code to do that. And if you need any examples on how to do something, just like Control F the whole code base to see how Unreal does something. So if you're like, I need to figure out how to load a texture, or I need to create this sort of thing or this asset or call this thing, just Control F and you'll be like, oh, well, Paper 2D plugin does this, and here's the code and how to do it, and then you'll be like, oh, okay, that's what I was doing wrong. Also, a lot of Unreal stuff does not work out of the box the way that you really want it to. It doesn't give you as much control as you really want on a lot of things. Like, stuff doesn't work perfectly. It works almost perfectly. And if you got the C++ code, you can kind of massage things a lot more easily than blueprints. Alright, so go right should be negative dir. Okay, so if this go right is true, go right should be false. It should always be go left to begin with. Alright, so if the vector x is greater than 0.92, then we're in domain 0. Alright, so else if vec.x is, let's see, greater than 0 and less than, what is 1 minus 0.923? 0.077f. So that means we're in domain 1 or 7. No, it's not less than 0.77f, it's greater than. Alright, so if the vector x is greater than 0.07, we are either 1 or 7. So if vec.y is greater than 0, then our start domain equals 1. And if vec.x is greater than 0.5, then go right equals true. So we'll do an else here. Start domain equals 7. If vec.x is greater than 0.5, is less than 0.5, then go right equals true. Yeah, if you ever need to catch up on any of my stuff, either it's you can catch everything that I've done pretty much for the past whatever on YouTube. So I post everything up there, so if you ever need to look at any videos or whatever, everything goes there automatically. And we're just kind of messing with stuff at this moment. So if vec.x is, if the absolute value Alright, man, you have a good one. And if you ever got any questions or you just want to share work you've been doing, you think it's interesting, just hit me up. And and have a good time. Alright, so if the fmath, the absolute value of alright, so let's see. Why don't we do the y stuff first? If vec.y is greater than 0.92f, then we are either in domain 1 or 3. So if we are in domain, our start domain equals 2. That's straight up. So if we go left or go right is based on our vec.x. So if vec.x is greater than 0, then go right equals true. Alright, so else if vec.x is less than I guess this is going to be 0.07. Alright, we want to do vec.x is less than negative 0.923f. So if that is true, then we are start domain of 4, and if vec.y is greater than 0, go right equals true. And right from there is like we're at 4, we're supposed to go to 3. Alright, else. So we need to detect if we're at so else if vec.y is less than negative 0.923, actually no, why don't we do the x again? So the x, if the x is less than 0.077, then we are 3 or 5. So if vec.y is greater than 0, then our start domain equals 3. And if vec.x is less than negative 0.5, then, or if vec.x is greater than negative 0.5, then go right equals true. Otherwise, start domain equals 5. So if vec.x is less than negative 0.5, then go right is true. Alright, so we got 0, 1, 7, 2, 4, 3, 5. We don't have 6, so we need to detect 6. So otherwise, our start domain is 6. And if let's just put some greater than or equal to stuff on everything here, just because. Alright, so go right, if vec.x is less than 0, then go right equals true. Alright. So I'm gonna do vector is %f, domain is blah. So we're gonna do vec.x, vec.y. It's a normalized vector, and I'm using the cosine of like 22.5 degrees and stuff like that in there. So that should translate to all these values. Start domain is 5. Effect.x is less than 0.5. Go right is true. Yeah, okay, that's correct. So I think this is probably the longest I've been streaming, except for when GOG hosted me for frickin' Pharaoh or whatever, and I went like 17 hours because I wanted to. But I should probably end it soon just because otherwise I'm not going to be effective tomorrow. You know, like, burn yourself out just doing random crap. I'm already going real slow, you know. Take some time out. It's true. Alright, so let's take a look at these. Vector is 0.2 and then 0.99. Domain is 1, go right is 0. So that is nearly straight up. So the domain should be 1, go right should be true because x is positive. So domain is 1 if vector, so x is greater than, alright, well vector y was greater than this. Start domain should be 2. What? You better stay for 1,000 more hours. Alright, so if the vector x is greater than 0.77, alright, so what is the cosine of 80 degrees? I guess, so what, it's 45 plus 22.5. I should do the cosine of 67.5 degrees. It's 0.38. Alright, so I got the wrong values going on here for these things. So maybe I should just do... Alright, so if x is greater than the cosine of 22.5, is this in radians? I hate how they don't document that, ever. Alright, so if x is greater, there'll be that. If x is greater than, we need the cosine of 60, what, 65? 67.5? So that's 0.382. Alright, so vector y, let's see the sine of 67. So the sine of 67 is this. This value is correct. So this value should be correct. This value will not be correct. So let's take a look after we do this. The cyborg deserves no mercy. That's true. We're just gonna, one day we're gonna show up over at Adam's place and just break his kneecap so he can't leave. He has to do work all day. It's gonna happen. But then I guess he'll get real cyborg kneecaps, right? And then we won't be able to stop him from running away. Because he'll be able to run too fast. Stupid cyborg kneecaps. What are you supposed to do about that? He's already chained to his desk? Yeah, I think the Bob's Burgers guys have something to do with that. You have no idea. I literally do not have any idea. This conversation is I'm sorry, Lucas. We talk about the real hard hitting truths in life in this chat room, and your coworker is kneecapping you because they need you to do work is a clear and present danger to folks like Adam. I mean, I worked at Amazon, right? They had that whole article about people crying under desks, stuff like that. All right, vector is 0.3295. That should be, domain is 2 and go right should be 1. All right, so we have a negative 0.8 and then a 0.5. So that should be a domain of probably 3. Go right should be 0 because it's farther left, so it'll be go left. So do we have any negative y's? I can imagine the article exists. Yes, the article most definitely exists. Okay, we are not... Are we? Yeah, I'm not convinced we're actually looking up our correct spot here in our field for movement. It's like we have this, and it looks like we have our pixels moving towards our thing properly, and then we've got like this flow field stuff that comes off, but it's wrong. 93 out of 120. You need to try harder, Lucas. No, that's impressive. I've heard that is an excellent game from many people. I think what's happening is all of our pixels are actually moving in the directions that they're supposed to go, and they're just all biased towards one direction. And what we need to do is we need to have a little bit more checking, I think. I think our movement direction needs to not work for this like space occupied. We need to not move into the direction that is next to a line. And the space occupied also, yeah, we're not checking anything for the actual height map data. So what we want to do is if the, yeah, so we need to change a few things. Is that Spock? Yeah, this is a Star Trek shirt. It's got good Spock and evil Spock facing off. That's just how we roll here in this basement. You know, shirts you can wear when streaming on Twitch, but you can't wear in real life. You know? Alright, so we need to check our data here for our map utils. We're gonna go check our, not our collision map, we're gonna want to see like if this is along, like this is space occupied. We need to check against the height map. So space occupied is going to have to know about its parent. So we've got to like pass through the calculated flow field as well. Alright, so space occupied needs this value. So let's go ahead and slap these in here. Alright, so we're going to need to take this reference, just forward declare it, and we're going to need to look up our current flow fields, make sure they don't occupy our flow lines. Look up our heights, make sure we aren't hitting shore. I mean, NCC 1701A if you want to be precise. You still know the show by heart, yeah. So we're gonna need our flow lines and everything else. Space occupied. So the tick needs to... Alright, so move particles is gonna need to take the flow field. And we're gonna need to call tick and flow field. So move particles will take that. Alright, space occupied. We are going to need to snag the... Alright, the map has stuff on it for the collision, but the paths in this thing? Alright, so for calculated flow path, path in flow field and paths, if path dot... Oh man, yeah, we don't have an easy lookup on this path. So what we're going to need to do is get like a T-map of int32 to a T-map, I guess a T-set of int32, and we have like path map, path lookup. So we're going to have like mpath.add, mpath.push, path.mpath.push. Yeah, okay, so and then we're going to go right here is going to be this path lookup. Where's the dang reset? Alright, so we're going to mpath lookup dot reset. Alright, so we path lookup dot contains cur.mx. So if this does not contain this, then mpath lookup dot add cur.mx tset of int32, and mpath lookup sub cur.mx dot add cur.my. And this is going to be path.mpath lookup, just like that. Haven't seen those in A minus was in the movies. I was talking about the series. Oh, okay. I see how it is. Alright, so we have our path lookups. So what we'll be able to do is go through our if path.mpath.lookup.contains x and path.mpath.lookup sub x dot contains y, return true. It is occupied. You cannot use it. Alright, and then we need to look up the flow field cached heights. So it's going to be int32 height index equals x plus m width times y. So if m cached heights sub height index, and it's the a value, equals 0, Return true. And that'll be flowfield.cached heights. Incomplete types are not allowed. What? Alright, well let's compile that and fix our errors. Yeah, well I kind of grew up watching the next generation Star Treks. Because, you know, that was coming out when that was kind of my generation. So we got our path lookups, we're passing stuff down. Let's just fix all of our errors. Alright, path lookup is undeclared. That is flow path map. Well, where the hell did we put the M path lookup? On the calculated flow path? Do we not have a reset for this? Okay, we don't have a reset because we don't need a reset for it. That makes sense. Alright, so we've got this tick on the flow path particle, which needs to take a class. You calculate a flow field reference flow field. So I'll fix those things. Yeah, I mean, as soon as Riker grew a beard, that was just like the best show ever, right? Some of the early ones were just freaking hilariously bad. Alright, space occupied does not take 2 things. That is true. It takes 3. Alright, so we're going to spawn a particle regardless of if the space is occupied on the line. And then it can move around. Crap, that's not what we want. Spawn space occupied and grrr. I guess we can skip it. So we'll just skip that. You actually saw him live? That's pretty cool. I like Picard and Q the best. Yeah, they were good characters. And they didn't overuse it either in the Next Generation. They overused the hell out of that in Voyager. It was just like, are you freaking serious? Let's take these beings that are so far beyond our understanding or whatever and turn them into a bunch of spoiled children. Yeah. It is pretty funny. Voyager is almost unwatchable at times just because of just technical mumbo jumbo speak that means nothing. Like, they at least tried another series, but Voyager just like went out the wall. And like, remember that time the dad from that 70s show was changing time and screwing everything up? Yeah, I remember that. That was just painful. Uh-oh. Uh-oh. Oh, okay, there it goes. Why is it taking so damn long to place? Is it because we're printing all this crap out? No, it's not because we're printing stuff out. It's because of something else. Did we add anything that's like super slow? I didn't think so. I think we added the lookup into, you know, the collision map. Like we have the for loop with the flow field paths. So maybe these dictionary lookups are actually pretty dang slow. So we should, instead of having a dictionary here, we should have a just an array. It might actually be faster to do a T array. Yeah, let's just do a T array of booleans. And we'll do like, yeah, just path lookup. So let's do alright, so we're going to, since we're passing this guy in, we'll do path dot init, and we're going to have false, and then it's going to be mmap.mwidth times mmap.mheight. And we're going to do set that. I'm just going to set it to true. So we won't have this path lookup strangeness. So we'll copy it when it works. Path.init. Actually, we can just go ahead and do the init. So we need, yeah, this path lookup dot init. Alright, so we got that set up, and then we need to go through, and it's if, you know, this index is going to be this thing right here, so it's going to be path.m. Oh, because this is a copy, Jesus. See, this is one of the things about C++. This ampersand right here turns this from a fully qualified object to a reference. And a reference is just like, take the object that we were going to use and just reference it, versus without the ampersand, it's like copy the whole damn object, and after you copy it, then use it. So what it was doing here is every single time it was doing a check on if a space was occupied, it was copying the entire calculated flow path, which is like a whole bunch of allocations. So that stuff I just did probably doesn't matter, but it's still going to be faster to do a lookup into a pre-calculated T array than it is going to be a map. And that's because a T map has like a lookup into like a hash table sort of thing, probably, and then it has another lookup into the T set versus T array, which is like we have all this memory, just check the memory at index, 5. So all it is you jump to the start of this thing and then you look up, an index array offset of that versus having like a map lookup. So indexing into arrays is constant time. It requires more memory to explode everything into an array, which is why you'd use a hash map or some other type of map there, because it will actually not have, it doesn't take space for keys that don't exist. Or it will, but it doesn't have to. It's dependent on the implementation of the map. So I think we've got enough memory to throw around here. Well, let's look at this in the content browser real quick for this texture. So we should be seeing a lot of, like, this is domain 3, which is getting used a lot. And was that domain 1? We're using 1, 2, 3, 5, which is 1, 2, 3, 5, which is this way, this way, this way, this way, and this way. And I'm not seeing any 6s, 7s, or 0s for these things. Something's wrong. Like, we got like something's flipped maybe? Like our Y's are flipped in world space or something? Because these pixels right here, like this rock should not be stopping these. These pixels should be wanting to go to the right here. So they should be wanting to move. Is our Y flipped? Just this value? Exploding. And I think it has to do with our... God, where do we have this, like, top left? So if our top left is negative and our bottom right is positive, our top left is negative and our bottom right is positive, then I think the Y is flipped. Like our top left should be negative 50, positive 50. So I think our Y value should be flipped. Let's see how that works. Card Q, what babyface? What you guys were talking about before? Talking about Star Trek, Lucas. Talking about watching TV. That's all. That's all I did as a kid. I watched TV. I went home and I watched Spider-Man on TV, and then I played like Link to the Past on my Super Nintendo, and I sucked at it, and I got better over time. Like Wayne says. I'm not sure what Wayne says. But will never be appreciated? Like, what do you mean it'll be never be appreciated? I think it is widely. People are like, which one's your favorite Star Trek? And like almost everybody says like Next Generation or Deep Space Nine. And they're always like, I really love the Dominion War. Like Wayne says. See, I mean, this might be something I shouldn't say on the internet, but I have not actually seen Wayne's World. Now the Y is not. I could flip the Y and it's definitely not doing what we'd expect. Like this thing should be wanting to move towards it, but it's not. Like I would expect this type of flow field sort of thing to be. Like you can see, like these values aren't even going down. Like they're just going out. Wayne's can't remember much. I know it's a classic. I feel bad about it. Let's try flipping the X, because the X is actually the Y-axis here. Maybe that's the problem. Maybe I'm using the wrong axis here. I should, like, WX and WY are wrong. They're just flipped. I need to actually, like, negate the Y, but the Y needs to be the X value. Christ, that might be right. Well, we'll see. I thought I was in the right space for this, but I might not be. You're a dragon anyway. Dragons are such snobs. Colt probably, I would guess. Karakan. That's pretty funny. The water's flowing in totally the wrong direction. It's like there it goes. It's going out. It's going out over there for no damn reason at all. Goodbye. let's just flip those axes and negate the y, which is the x. God, Fight Club is so damn played out. Like, it was all edgy and cool when it came out. And then I think over time it's just too many people think they're like super badass because they watched it a couple times or something. Just looks like the Y is going the wrong direction. So maybe I just needed to flip the X and Y axis for this. You can go on forever. Yeah, I mean, and of course the Dune you're talking about is the like 1980s Dune, right? The one that's like 14 hours long. And of course has Patrick Stewart. No. The slow blade penetrates the shield. It's like they tried to recreate it, and I was just like, halfway through like the recreation, I was just like, you know what, to hell with this recreation. This thing sucks. And I just like popped in the other Dune. The new one, yeah, there were like two new ones. They're both awful. They're like, you know, made by the Sci-Fi Channel or some shit. This is all sorts of screwed up, isn't it? Yeah, like these should be detecting nothing there and just moving into it. Alright, well, I think probably what I should do is I should probably be done. Because this should be a pretty simple operation, and looks like it's all sorts of screwed up. Is the X supposed to be negative here? Yeah, what, John Carpenter's The Thing? That's definitely one of the good ones. Didn't they also make like The Thing 2 or something? I don't know. The one with Kurt Russell. That's a good one. Cheating bitch. Oh yeah, prequel, right, that's right. I think I watched it once. That thing as well, yeah. Something's wrong. Something's just. Because like these pixels should be wanting to go this way, but they're not. And why? What direction? Like if this is X and Y. Like X and Y in the texture looks like this. I think the math was correct.